So last night on your homework, you came across some problems that involved working with the least common multiple, which means really, if you remove the greatest common factor they share out of the picture, what other factors do these two numbers share? That's going to help you develop an understanding of where will they meet in their flow, in their sequence of multiples. I saw someone once draw multiples in this way. For instance, 2's happen, now this is not going in any particular spot, but 2's kind of look like this. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, right? But 5's take a little bit longer to make a pattern of them, right? So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. You know what I'm saying? Yeah. So their frequencies are different.
We can just write all this, please, not for answers.
Please stop. What I'm trying to get you to see visually is that the patterning of the repetitious multiples continues infinitely. And everywhere where there's an intersection of two lines, that's a spot where their multiples meet. And it happens again, and it happens again, and it happens again, infinitely, in a predictable way, in a predictable sequence. Number 10 in particular, I think maybe there was a breakdown in people just not looking at the instructions a little bit closely. It says use the train schedule over here, but they're only particularly want you to focus on the blue and the green train lines. So the blue and the green train lines have this repetitive sequence of 8, 8, 8, and 10, 10, 10. So when will those rotations arrive at the same time? After how many minutes have expired? So we're going to have to do the least common multiple between 8 and 10. Now, if we were doing that Lego block metaphor, what's 8 composed of, boys and girls? 2, 2, and 2, right? Remember the 3 yellow blocks? Yellow, yellow, yellow. And what is 10 composed of? A 2 and a 5, right? A yellow and a green. So you recognize that they both have what in common? They share a 2, right? So let's get rid of the additional 2 involved and combine the remaining factors. If you collect them into one number, one factor, let's see what that would look like. So that's 2, 2, and 2. And 10 is 2 and 5, right? So I'm getting rid of, see how they have duplicates? I'm getting rid of the duplicate and then combining the leftovers. So 2 times 2 times 2 times 5 is going to be equal to 40, right? So if I did that in terms of using just a multiple stream, I would see that it goes 8, 16, 24, 32, 40, dot, dot, dot. And if I did multiples of 10, what do you notice they meet up at first? 40. Where will they meet again? 40 more, which is at 80, right? So the first occurrence is at 40 minutes. Then they will meet again at 80 minutes, and then 120 minutes, and so on. So there's 2 different approaches, and I don't mind which one you use. The factoring method, you have to be able to say, they have this in common, get rid of it. But the listing method might take you a little bit longer, especially if the numbers involved are bigger. But you can see exactly where's the first occurrence that they have a common number at, a common multiple at 40. So that was the just the only one I really wanted to look at for page 100. Now for today's exercises, people at home, on the Google Classroom post, you have something that looks like this maybe attached in the Your Work section, the Chapter 6 review. And you'll notice as you click through it that there's 4 different skills that we're going to work on. I'm going to be doing them here on the board. I'm going to have people dragging the objects to the appropriate place, but it would be more helpful if you at home pulled up your own screen and worked on manipulating them on your own, since I can't give you access to touch the screen I'm working on here. Does that make sense? So open up your Google Classroom post, and in the Your Work section, you'll see this very same slideshow. It says Chapter 6 Review. And you'll be able to, once you open it, you'll be able to look at the instructions here, and you're going to be able to click those objects and drag them into the spot where they belong. So we're going to do these together as a group, and then we'll wrap it up with an independent practice worksheet that you can use as a study guide for tomorrow's quiz. Okay? So the first skill that we worked on involved awareness of prime and composite numbers, right? Could you name for me the prime numbers that exist between, let's just go 0 to 20. Ready? Go. 2, 3, 5, 7, 11, 13, 17, and 19, right? Those are the prime numbers that are the most frequently used. And therefore, we want to get really comfortable in being able to bust a number up into primes, bust a number up into those Lego building blocks, because they help us manipulate them in other ways. So I'm going to ask someone here in the classroom, let's kind of minimize it a little bit so that it can be moved. I'm going to be moving these little objects around, okay? Where should I move the one that says 2 times 3 to the 2nd power? This is the prime factorization of a particular standard form number. Multiply those numbers up, stack them up as a Lego tower, and tell me what number does that represent? What does 2 times 3 to the 2nd represent? What do you got, Gavin?
18.
He's saying 18. So I'm going to click it and drag it next to 18. Make sense? All right, let's grab another tile. And I'm hoping you're able to do this from home as well. Where would, let's do this one. 3 squared times 7. Where would 3 squared times 7 belong? Where would that one, Isabella? She said 53 or 63? 63. All right, let's drag this one down to be with 63. All right. We see another one? Anyone want to go up to the board and see if you can select and drag it into the spot? You want to see if you can do that, Isaac? Want to try it out? So go click a tile and see if you can drag it to the place that it belongs. You might have to touch it to select it. There you go. Nice. All right. Someone want to come on up and grab another one? All right, go ahead, Finn. Touch one of them to select it, and then you can do what you want with it and drag it. Here, let me get it out of there for you so that it might be draggable. Okay. 3 times 5 to the 2nd. Point where you want it, and I'll put it there. Three times 5 to the 2nd power. Feel free to type in the chat box so I can see how you're doing at home. Where does 3 times 5 to the 2nd power belong?
75.
Right here. Thank you. All right, go ahead, Zoe. She's taking the one that says, or trying to, Is it not letting you click on that one? Okay, there you go. You should be able to take it now. There you go. She took 2 squared times 11 to match up with the standard number 44. And that's sort of like busting it up into primes. Notice those prime numbers are in increasing order. So 2 is a smaller factor than 11. So I put 2 squared before the 11 in increasing order. Got another one for me? Go ahead, Evan. I have 4 more left on this tile. Which one you want? This one? Oh. You broke it. Wah, wah, wah. Everyone give Evan a hand. Oh man, oh man. Technology is my friend.
Evan, I was gonna put the exact same thing.
Here we go. I think I've got it. All right, Evan, we're back. We're back.
Crash it again.
Don't crash the system again.
Evan, try to think.
Where does 2 times 3 to the 3rd power go?
Crash it good. Yeah.
Here, I will, tell me where to put it. Where?
54.
He said 54. All right, let's see what people at home are saying. People at home are agreeing here. It belongs with 54 because 3 times 3 times 3 is 27. 27 times 2 is 54. All right, couple more here. How about class, all of you? Where does 2 to the 5th times 3 belong? Just say it out loud. 2 to the 5th times 3. 96. Okay. Where does 2 to the 3rd times 5 to the 2nd exist? 200. Nice. And 2 to the 4th times 3? Ding, ding, ding. All right. I'm going to quick put all these pieces back for the next class. I know. I made this little activity for us to do. All right, I'm going to go on to the next slide. Greatest common factor. Now, you're probably getting good at being able to break apart a number and see it for what it's worth in a collection of its primes. And then its primes would be, you'd look at the 2 values and say, what do they have in common? Collect the things they have in common into one pile, and that would be your greatest common factor. One way we did this was with factor trees. Another way we did this was by building the number with Legos and then looking at what factors or blocks they had in common. So tell me with this first one, this first tile, what number would be the greatest common factor between 12 and 30? 60. No. Not between 12 and 30. Not the greatest. You know what I think you're thinking of, Shane? You're thinking of the least common multiple.
Oh, yeah.
And that would be 60 for these two. The least common multiple they share would be the lowest copy that they have in common. But the greatest common factor is now bust up 12 into primes. What do you get? Make a factor tree if you need to. Bust up 12 into primes. Bust up 30 into primes.
I got 2.
They share 2. And what else do they share? It is, and if you keep breaking it up, you'll notice that they have that in common, right? So they share what greatest common factor? They have a 2 in common, they have a 3 in common. So when I put them together, what do I get? What's 2 and 3 together as a factor make? Boys and girls. Are we talking about multiplication or addition when you're talking about factors? Multiplication, that's right. So snap together those Legos, right? So where should I put this one? How about 32 and 48? Can you make a factor tree real quick? Or envision the Lego towers? How do those two numbers relate to each other? If you're at home, please type it in the chat box if you are making your own factor tree to decide what is related between these two. Allie, what do you got for me?
8.
She's suggesting 8. Now, how did you come about that?
I didn't do that. I did it in my head.
Okay, so were you envisioning like the Lego towers that we made or just the factor trees themselves? Factor trees themselves. So when she got down to it, she knew that they had lots of 2's in common with each other, right? What are the leftover factors involved here? If the ones that you didn't use. So I'm looking for an 8, you said? Okay. So if I remove an 8, then they still have another 2 and another factor involved. Do you think it could be 16 maybe could be their greatest common factor? I'm going to make a factor tree just to be sure, okay, on paper. So let's all do the same because I think this one might be 16, but the way I can tell for sure is by busting it up into all primes. And when I do that, I'm finding that 32 has 5 2's, 2, 2, 2, 2, 2. And 48 has 4 2's and 1 3, right? Did you get that prime factor, team? So if they share 2, 2, 2, 2, if they share 4 2's, then what number does that build to be when you put them all together? What is 2 times 2 times 2 times 2 altogether? 16. So in this case, do you see how just that one extra factor of 2 gets involved and we have to put 16 for this one? So the factor tree works every time. It's just a little bit of discipline to get it on the paper to see it in print. Oh, this one's pretty big, 96 and 63. Do you know the common factor between them or do you want to bust it up into primes? What would 96 break up into? Sure, 12 and 8. And then keep breaking it up. 2, 2, 2 for 8. And then 2, 2, 3 for 12. That is a lot of primes. 63, 3 times 3 times 7, right? Are you making factor trees here? And what do they have in common with each other? Go ahead. Just 1 3. After all that, they just have 1 3 in common with each other. So therefore, their greatest common factor is going to be what? 3. I thought it was going to be a bigger number since they are bigger numbers. But the fact is they only have 1 shared factor, 3. All right, what about between 24 and 40? Want to make some factor trees or are you starting to be able to do this in your head? Izzy's saying 8. And I know that's true because when I remove 8 from the 24 and I remove 8 from the 40, I get 3 and 5 as left over and they don't have anything in common, right? So 8's going to have to be the one that goes here. What about between 42 and 63? What's their greatest common factor? 7. Yep, 7's their greatest common factor. Let's see. Oh, yep, there's a 7. What about between 35 and 12? When I break that up into primes, I'm looking at 35 and I get 5 and 7. But when I'm comparing it to the factor tree for 12, 2, 2, 3, They don't have anything in common with each other, do they? So what do you think, Evan? None. They do not have a greatest common factor. You got it. All right. Let's see. Between these ones remaining here, what do you think? Where would 14 go? With which group? 14 and 70, yes. Where would the 15 go? This one, yep. And this one, they definitely share a common factor 25. Nice. Okay, backwards. Do. Distributive property. This you did so well at when we did the memory game. And we matched up expressions by either passing out or collecting a factor from each of the terms, okay? So when I point to a particular card, like I'll put it up here, let's just say, what is the sum that it belongs with? So pass out the 8. What's 8 times 8? Say 64 plus what? 40. All right. Say it a little bit louder for me, everybody. Ready? I'm going to take this card now. What's this one? 63 plus 84. Thank you. Okay, louder, please. What would this one be? 44 plus 20. Thank you. What would this one be?
10 and 12.
10 plus what? 10 plus 30. Where is it? Oh, Mrs. Moore had a typo. There it goes. What about this one?
25 and 45.
All right. What about this one?
12, 15.
What about this one?
24 and
What about this one?
16 and 56.
And what about this one? All right. All right, let me get those back where they were. And I have to switch out that. This one was supposed to say 30. So sorry about that. All right, last one, least common multiple. These were what we did last night. So you're recognizing what is the first occurrence that these two numbers have a multiple in common with each other. And this is what Shane was really good at. 9 and 6. Where's the first time their multiple streams meet? 9, 18, 27. Where did they first meet?
18.
Was that you? Or the Do you agree with them? Erin agrees with you, whoever was saying that from home. Very good. How about between 3 and 9? When's the first time they meet? 9. Not too bad here. How about 6 and 7? Maybe it's this one here, 42. Yep. I know 6 and 7 won't meet before they meet each other because they don't share any factors. So the first time they meet is when they come to the opposite multiple here. How about between 4 and 8? When's the first time they meet? 8. How about between 4 and 10? I don't have a 40 here. It's 20 is the first time they meet. How about between 5 and 4? How about between 6 and 10? How about between 8 and 9? They don't share any factors, so it's going to be at their meeting. Yep. Very good. Get them all back here. Good job. And then for your independent practice part, I've got a little 4-square assignment. There's 4 examples of each just for you to do independently for homework if need be. We've got a couple minutes here left of class. I'm going to collect this tomorrow. You'll have a quiz tomorrow on this material, a little bit from each section, okay? Got it? All right, I'm going to pause my recording here to just pass out papers. But if you guys need anything else, I'll be back in just a second, okay?